Hello. In this video, I will show you some of the available options to load new meshes in Interface Equilibrator and to export them. To load a new mesh, one option you can use is given by the built-in meshes. You can choose among different shapes, and then each shape has different parameters available to regulate its size and aspect ratio. For example, I select the cube, and then I increase its height. To load a new fluid interface mesh, you can also choose to select among different built-in meshes. For example, I select the circular meniscus, and I increase its radius. By clicking this button, I can open the tool to check the 3D position of individual vertexes of a mesh. This can be convenient to decide how to translate opportunely the loaded meshes. For example, to translate the circular meniscus to the middle of the vertical pillar, I need to translate it in Z by 2 micron. We will now remove the facets in the middle of the circular meniscus to create a hole. Now the meniscus has 2 boundaries, and we want to use the vertical pillar as constraint for its inner boundary. So, firstly, we edit the names of the 2 boundaries to remember which one is the inner one. We want to simulate a flat meniscus far away from the vertical pillar. So, we select, as constraint for the external boundary, displace only in Z, and we leave 90 degrees as contact angle. For the inner boundary, instead, we select the vertical pillar as constraint, and we set a contact angle of 60 degrees. We can now launch the equilibration. Since we would like a more refined mesh near the pillar, we edit the equilibration settings, selecting a higher degree of refinement, and allowing the refinement of meshes with also a higher number of vertexes. And then we relaunch the equilibration. Due to the vertical pillar's wetting properties and shape, we have obtained a monopolar capillary deformation around it. The fluid interface mesh that we obtained can now be saved by several options. For example, as a file in the portable STL format, or as a file in the ietm format, which is a format specific for Interface Equilibrator. The ietm format has the advantage that, if you reload the mesh ietm file, then all the settings of the mesh are also reloaded. The STL format, instead, is convenient to import and export meshes from other applications. For example, we can save this fluid interface mesh as an STL file. And then we can load it in another program. And we might also have a mesh saved in the STL format from somewhere else. For example, I now download this STL file from Wikipedia. And then I load it in Interface Equilibrator. And I can now use it as a solid surface. For example, I tried to simulate a droplet near the handle, selecting a contact angle of 40 degrees on the teapot. However, it does seem, for this droplet volume, that the droplet is trying to wet the whole handle of the teapot. So, we actually need to use an initial fluid interface mesh with a toroidal topology to obtain the correct equilibrium shape of a droplet with this volume. I will now show it to you, since it is an instructive example. Firstly, we'll load a mesh with this topology. I created this particular shape for the droplet's initial mesh, because when I set the solid surface as constraint for the 2 boundaries of the droplet, I need that all the droplets mesh edges going from a boundary vertex to an internal vertex remain on the same side of the solid surface. In another tutorial, I will show how you can create shapes like this using Interface Equilibrator's tools. To set the desired volume for the droplet, we first launch a first equilibration where we keep the mesh refinement very low. And then we can launch further equilibrations and set a negative fluid volume variation to gradually shrink the droplet to the desired volume, while keeping this low mesh refinement. And we repeat this process in steps until we reach the desired droplets volume. Finally, once we have reached the desired droplets volume, we can launch a final equilibration to improve the mesh refinement to the desired degree. And we switch off the fluid volume variation. Thank you for having followed this video. For more information and for other tutorial videos about Interface Equilibrator, please visit our website.